Hi everyone, and welcome back to Fundamentals of Engineering with Farhad. Happy New Year! Fluid mechanics. We want to calculate the flow rate in a horizontal venturi meter which is connected to a water main and gets the water from the water main. From here, water, water enters to the horizontal venturi meter through an entrance hole of 45 centimeters and it just moves forward until it reaches to the throat and the diameter decreased by one-third from 45 centimeters to 15 centimeters at the throat of the ventrimeter, and the ventrimeter itself is connected to a differential manometer which is filled with water and also mercury. The legs in mercury has a different in height by amount of 37.5 centimeters and the specific gravity of mercury is 13.6. We want to calculate the flow rate which passes through our ventrimeter. So our example is a horizontal ventrimeter with a diameter of 15 centimeters at its throat and a 47 centimeters entrance and connected to a differential manometer which is partial with mercury, the other is filled with water, and the difference between the legs of mercury is 37.5 centimeters. If we ignore the friction losses, we want to calculate the flow rate in terms of cubic meters per seconds. Let's start our problem. In approaching our problem, to solve this problem, we start with the Bernoulli's equation, which says the this term for cross-section 1 should be equal to the same term for cross-section 2. Z1 plus P1 over gamma plus V1 squared over 2G should be equal to the same term for the cross-section 2. And because point 1 and 2 stands at the same elevation, so Z1 and Z2 cancel out from our equation, and then we can rearrange our equation. So P1 minus P2 over gamma is equal to V2 squared minus V1 squared over 2G. And also we can jot down the discharge passes through the ventrimeter remains the same, so A1 times V1 is equal to A2 V2, and if we just jot down V1 based off V2 and replace it in the equation, you can easily see we can bring this V1 directly from this equation in second terms of our equation, and then P1 minus P2 over gamma 1 times 2G is equal to V squared 2 out of bracket 1 minus A2 over A1 squared. As soon as we have this equation, we can easily see the only unknown in this equation is velocity, because the area and pressure we can calculate it. Let's jump to that. So if we start from point 1 and moves down, the pressure increased by the amount of 30 point rho gh. So this is our h rho w because we are in water times g minus, and if we just move up this amount in mercury, that's the same height but this time rho mercury times g, and rho mercury is 13.6 times rho w times g, and we reach to point 2. As soon as we have our point 1 and point 2, and we start from point 1, moves downward, come up to point P2, and now we know what our pressures are. So rearrange our equation. It just gives us P1 minus P2 is 12.6 rho W times G times 37.5 centimeters, or negative times to 10 negative 2 meters squared meters. So it just says P1 minus P2 is equal to, if we just bring it to the top equation, we can cancel out the rho g. So this is the first part of our main equation, and it just gives us part A is equal to this term. Let's work around part 2, and the only unknown in our equation is velocity. As soon as we get the velocity in throat, we can multiply it by the area which is provided to get the flow rate, because Q is equal to A2 V2 or A1 V1, whatever you want. So let's work around the second part, and definitely as soon as we have velocity, we can get the discharge, which is our what we are looking in our problem. So this part is v2 squared times a2 to a1 squared is d2 to d1 to the force. And if you do the math, definitely d1 is 3 times bigger than d1 d2, so d2 to d1 is 1/3 to the force. And if you do the math, it just gives you what the part 2 is. So if we have our part 1 equal to this term, and our second part 2 equal to this term, and part 1 should be equal to term 2 based off the Bernoulli's equation, and we can easily calculate the velocity in the throat as soon as we have the velocity at throat. So substitute the numerical value, and it just gives us v2 is equal to 9 point almost 69 meter per second. And as soon as we have the velocity, calculation of discharge is pretty straightforward. A2 is pi d squared, d2 squared over 4 times velocity in cross section 2 or the throat. And if you do the math, it just gives you a discharge based off meter cube per second, because the area is meter squared, velocity is meter per second, and it just gives us the numeric value of discharge is equal to 0.17 meter cube per second. That was what our exactly we're looking for, and the closest answer to our calculation is choice B. Thank you. We'll solve more multiple choice questions related to FE and P exam, in terms of fluid mechanics. Thank you.